Interest is an amount of money paid by a bank for the privilege of borrowing your money. The bank or lending house uses this money to pay for other people's homes, car, and other types of loans. This amount that you're given is based on a percentage of the amount of money that the bank borrowed. The amount of money earned is a result of an investment. That's another way to think of it. So it's the money you earn from investment, or it's the amount of money you earn. Sometimes a checking account may earn interest. You can also think of interest as an amount of money that you're paying to a bank when you take a loan from them. When calculating interest, there's a couple different formulas. There's the simple interest. To look at our variables, let's break them down. Interest is, again, the amount of money paid in return for borrowing or investing money. The principal is your starting amount of money, your initial investment. That's how much money you put into the account. That's how much money you invest in the stock or the company. The rate is the interest rate written as a decimal. So this is actually a percentage given. So you may have a 3% interest rate or a 10% interest rate on a higher yielding account. We always calculate a percent using a decimal. Time is the time money is invested or borrowed in years. Since we're representing years, we need to look at other ways to look at other amounts of a year. So 1 month, for example, I couldn't put just one because I'm representing a year, but 1 month is 1/12 of a year, which as a decimal is 0.083. So a couple different ways to look at this. 5 months, for example, that would be 5 out of 12. So instead of putting 5 in for the time, you put 5/12, or you could put it in as a decimal at 0.417. 1 week, well, there's 52 weeks in a year, so 1 in 52. Likewise, you could turn it into a decimal if it's easier to put into your formula. When evaluating an interest problem, you need to follow the following steps. Identify the given information in the word problem. That's always important when you're dealing with a real-world situation. Find the given information. So in this case, we know that it's for 9 months. Well, 9 months is going to represent our time. I can't just use 9 because I have to represent it as years. This might eventually be 9 out of 12 months in a year. We're given a rate, so this is our percent. I know I need to turn that into a decimal before I can calculate with it. And I'm depositing $350 to begin with. This is my principal. This is how much money I put into the account to begin with. Now I'm going to substitute values in for the appropriate variables. I'm going to be using my simple interest formula. I know to use simple interest because it doesn't talk about compound interest, which we have not talked about yet. So I have my formula. I'm going to write it out. Replace all the variables with parentheses. Now I know that I can't use 2.1%. I have to use the decimal version. So I move that decimal over 2 places. I'm going to put 9/12 as a decimal as well. 9/12 comes from 9 out of 12 months. So now I have easier to use or manipulate values of my rate, which is 0.021, and my time, 0.75. It's 7.75 or 75% of a year. That's what 9 months is. Let's substitute everything in. Each of my variables is replaced by a set of parentheses, so I have a place to plug everything in. My initial investment, my principal, was 350. It was at a rate of 0.021 or 2.1%. It was the interest was being accrued for 9 months, which is 75% or 0.75 out of a year. Now I can evaluate the substituted algebraic expression using the order of operations. All I have here is multiplication, so I'd end up doing 350 times 0.021. I underline, I evaluate, I rewrite everything. Last thing I do is 7.35 times 0.075. I underline, I evaluate, and there's my final answer. Now, here's the difference. You have to ask yourself whether they're asking how much money is in the account or just for the interest. If the question's asking just for the interest, here's our answer. In the last 9 months, my account accrued or earned $5.51. If they ask for the amount in the account, that includes your principal as well. So you're going to have to add the interest to your principal if you are finding your final balance. the total balance. So in this case, I put $350 in there. I earned $5.51. So my total account or my total balance right now is $355.51. The other interest formula we have is compound interest. Compound interest works a little bit differently than normal or simple interest. Compound interest is added to the principal of a deposit or investment so that the added interest also earns interest. To think about this another way, instead of getting an interest balance added on every 9 months, every year, if it's compounded, then it adds on every quarter, every month, every week in a magic case. This means that every time they use the interest rate to calculate how much more interest you've earned, they're using it on a larger value. So if the interest is added in and then a rate is calculated out, you'll earn more money each time. So compounded interest earns you a lot more. So the interest is compounded in time intervals per year. So just like we saw with time in the simple interest formula, we are going to have to relate time as a year. So a week is 1/52nd, a month is 1/12th, etc. Let's identify the formula's variables. The balance is the amount that remains in your account. So that's how much money you have total in your account. This is unlike the simple interest formula that just tells you how much interest you've earned. We have our principal, which is the same, just like our simple interest. It's the starting amount of money. It's the initial investments, the amount of money you took out. Your rate is your interest rate written as a decimal. It'll be given to you as a percentage, but remember to turn it into a decimal. N, which is used twice in this formula, represents the number of times the interest is compounded per year. So this is where knowing that there's 52 weeks in a year, that there's 12 months in a year, that there's 4 quarters in a year, that there's 2 halves in a year, that's where it really comes into play. This represents the number of times per year that your account calculates or adds back in the interest to your balance. If you're taking a percent or an interest percent of a higher balance each month, you're going to be making more money per month. And then T is going to represent the amount of time that the money is borrowed or invested. And this again is in terms of years. Let's examine a couple common ends or intervals. So if your interest is compounded yearly, end's going to be 1. It's 1 time per year. Semi-annually, that's twice per year. Quarterly is 4 times per year. Monthly, because there's 12 months in a year, there's 12. Weekly, there's 52 weeks in a year. And daily, which is a perfect example of how compound interest can make you a lot of money, daily would be 365 because there's 365 days in a year. Let's do an example problem here. We need to follow the following steps. Always start by identifying the given information in our word problem. So here I have 2 years, so I know that's how much time it was invested. I know that it was invested at a rate of 5%. My initial investment or my principal is $1,200, and its interest is compounded quarterly, so that's 4 times per year. In this case, I know to use the compound interest formula, not the simple interest formula, because it tells me that it's compounded. That's when you use one formula versus the other. If it says compounded, you use the compound interest formula. Otherwise, assume it is simple interest. We're going to substitute values in for the appropriate variables. So I'm going to set up my formula. Here's a couple of pieces of information I want to clarify. 5% is really 0.05 as a decimal. Quarterly is 4 times per year, and there's my formula. I'm going to plug each value in for its missing variable. Sometimes it helps to write parentheses around the variable so I know exactly where to plug things in. I put 1,200 in for P, the principal. 1 remained 1. My rate was 0.05, so that's 5% as a decimal. N, both of them, is going to be 4 because it's quarterly, 4 times per year. And it was for 2 years, so T equals 2. Once everything's substituted in, we need to evaluate the substituted algebraic expression using the order of operations. This is a real test in the order of operations. There's some exponents. There are borderline nested parentheses here, so you be very careful. So as I go through, I see inside my parentheses, there's division technically, or I could look at that as a separate expression of 0.05 over 4. Regardless, it comes out to be 0.0125. I'm then going to add 1 to that. Up top, 4 times 2, I'm going to simplify that first to make it 8. Almost treat that like a parentheses. Now I'm going to follow the order of operations still. I have nothing left in parentheses, nothing grouped that way. So I'm going to take my exponent, so 1.0125 to the 8th power, times 1200. So I end up with a total amount in my account of $1,325.38. Now in this case, the problem isn't just asking how much money is in my account. It's asking how much total money will I earn. In order to find this, I'd have to subtract $1,325.38 minus $1,200. So my true final answer to this problem is $325.38 because that's the difference between what I invested and what I finally had as my balance in my account. Let's try a problem. You have a principal of $530. That's how much money you started with. Your interest rate is 3%. Remember, that needs to be a decimal. It's compounded monthly. So I know that compounded means I need to use my compound interest formula. Monthly means 12 times per year. And it's going to be going for 2 years, so my time is 2. Remember, 0.3% is 0.03. Monthly is 12 times, so n is 12. I take my original formula for compound interest and I substitute values in. My initial amount, my principal, is 530. My rate of interest is 0.03. I have to write it as a decimal. I can't just write 3%. It's compounded 12 times per year or monthly. So that's n down below, that's n up top. And then it's for 2 years, so t equals 2. I'm going to start doing the calculations. It's going to be the same order every time. I'm going to take care of that fraction, or think of it as division. 0.03 divided by 12. I'm still inside the parentheses, so I'm going to add that to 1. 12 times 2 treats itself like a set of parentheses are grouped up there. 12 times 2 is 24. Now I'm going to take care of my exponents first. So 1.0025 to the 24th power. Throw that in your calculator. Multiply that by 530, and that's how much money we have in my account. Now again, it's asking how much money will be in the account for 2 years. That's how much. If it was asking how much have you earned, we'd have to subtract. $562.73 minus 530 would give you $32.73. Be careful what it's asking for, whether it's the interest or the total balance. On your own, try the next example. Figure out which information is given to you and which formula to use. It's asking for how much will you have earned. So it's asking for the total interest, not the total balance.